Hello friends, this video on work and energy part 5 is brought to you by examfear.com. No more fear from exam. Now that we have talked about work and energy, let us quickly talk about power because these three are very closely related to each other. So what is power? Power is the rate of doing work or rate of transfer of energy. So that means power actually tells us how fast or how slow work is being done. Let us suppose I have to do work. What is my work? Let us suppose I have to move a box from one position to another position, right? So for that, what will I do? I'll apply some force so that the box undergoes displacement and it reaches from point A to point B. Now the question is, different people can do the same work in different time intervals. Somebody will do it very slowly, somebody will do it very fast. So that rate of doing work, the rate at which the work is being done, that is known as power. Let us take the example of a person who is on a bicycle and another person who is on a bike. So what happens if you tell them that both of them have to reach a particular destination? What do you observe? You observe that the person on the bike reaches there faster as compared to the person on the bicycle. That's because the power of the bike is more. That is the rate of doing work. The rate at which work is done is more in case of bike as compared to the bicycle. Let us take another example. Suppose you have a small kid and you ask her to run. You have another guy who is around say 15 years old, who is also little more energetic. So you will see that this guy runs faster than the small girl. Now you compare that guy with another athlete who is like full expert in running and jogging. So you will see that this guy would be running the fastest. So that means the power of this guy is greater than the power of this guy, and the power of this guy is greater than the power of this small little girl. So power is all about the rate at which you are doing work, how fast or how slow you are doing a particular work. So you see that the strongest guy will take the least time to reach a particular destination. The second guy will take lesser time, and the small girl will take lot of time to reach the same destination. So this is all about power. So how do we measure power? The SI unit of power is watt. 1 watt is defined as the power when work is done at the rate of 1 joule per second. So how do we mathematically define power? Power is given by work done by time taken or energy transferred by time taken. There are some larger units of power like kilowatt, where 1 kilowatt is equal to 1000 watts. So now that we have talked about power, let us talk about one small thing which we missed out, that is commercial unit of energy. So till now I was told that energy is measured in joules, but joule is a smaller unit of energy. Now you would have seen that when the meter reading of your house comes every month. So a guy comes, he checks your meter and he tells you how many units of electricity have you used. So what is that electricity? Electricity is nothing but electrical energy, right? But they do not measure it in joules. They don't say that you have utilized 5000 joules of electrical energy. They don't say it like that. So how do they tell it? They tell it in units. They say that, okay, your electricity usage is say 50 units. So what is that unit? That is a commercial unit of energy. So the commercial unit of energy is kilowatt hour. So it is kilowatt hour. And how do we relate kilowatt hour with joules? 1 kilowatt hour is equal to 3.6 into 10 to the power 6 joules. How do we get that? 1 kilowatt hour is 1 kilowatt is 1000 watts. So this will be 1000 watts multiplied by 1 hour is 60 minutes and 1 minute is 60 seconds. So this is 60 into 60 seconds. So this becomes 3.6 into 10 to the power 6 joules. Right, so 1 kilowatt hour is 3.6 into 10 to the power 6 joules. And 1 unit which you generally see in your electricity bill, that 1 unit is nothing but 1 kilowatt hour. So that means if you see that your electricity bill has 10 units of usage, that means how many joules of energy have you used? 10 into 3.6 into 10 to the power 6 joules. Right? Okay, so with this, we will conclude this lesson on work and energy, and I hope that I have been able to explain you the basic concepts of work and energy. So let us try to solve some problems based on whatever we have studied so far. So here comes problem 1. It says that a certain household has consumed 250 units of energy during a month. How much energy is this in joules? So how many units? So 1 unit is equal to 1 kilowatt hour, right? So 250 units will be equal to 250 kilowatt hour, right? Now we know that 1 kilowatt hour is equal to 3.6 into 10 to the power 6 joules. Therefore, 250 kilowatt hour will be equal to 250 into 3.6 into 10 to the power 6 joules. So this is equal to 9 into 10 to the power 8 joules. So this would be the energy in joules. Let us look at the next problem. It says an object of mass 40 kg is raised to a height of 5 meters above the ground. What is its potential energy? So when you raise an object to a height, to some height from the ground, the work done on the object when you raise it to this height is stored as potential energy. And we also know the expression for potential energy as mgh. So what is m? Mass of the object, which is 40. G is acceleration due to gravity, that is 9.8 meter per second square, and height is 5 meters. So this is 1960 joules. So this is the potential energy of the object. If the object is allowed to fall, find its kinetic energy when it is halfway down. So now if you allow this object to fall, what happens? This potential energy will only get converted to kinetic energy. So now if you look at it at this point, let us call this point as A, let us call the lower point as B. Now at point A, the total energy is potential energy. At point B, the total energy is kinetic energy. So what happens at halfway? So halfway is point C. So at point C, the energy is half kinetic and half potential. So at point C, energy is partly kinetic and partly potential, right? So that means kinetic energy, that is kinetic energy at C will be equal to 1960 divided by 2, because the total energy will remain 1960 joules at every point. As per conservation of energy, at every point the total energy would be 1960 joules. So at point C, this total energy is half kinetic and half potential. So kinetic energy would be 980 joules. Right? Okay. So let us look at problem 3. It says an electric heater is rated 1500 watts. How much energy does it use in 10 hours? So the power of the heater is given as 1500 watts and the time for which it is utilized is given as 10 hours. So what is 10 hours? 10 hours is 10 into 60 seconds. So that is equal to 36000 seconds. Now by definition of power, we know that power is equal to work done by time taken or energy transferred by time taken. So we can say that energy will be equal to power multiplied by time, that is equal to 1500 multiplied by 36000 seconds. So that is equal to 540 into 10 to the power 5 joules, which can be written as 54 megajoules. So this much would be the energy that it will utilize in 10 hours. Let us look at problem 4. An object of mass m is moving with a constant velocity v. How much work should be done on the object in order to bring the object to rest? So what is the initial velocity? We normally denote initial velocity by u and final velocity by v. Initial velocity of the object here is given as v. So let me denote this v like this, right? So this is my initial velocity. What is my final velocity? Now I want to do some work on the object such that the object comes to rest. So that means final velocity is 0. Right? So work done is given by force into displacement. What is force? By Newton's second law, it is mass into acceleration. And what is displacement? From the third equation of motion, v square is equal to u square plus 2as. In this case, v square is 0, u square is v square plus 2as. So from this we can say s is equal to minus v square by 2a. So here you can write s as minus v square by 2a. So this a and a will get cancelled. So this will be minus half mv square. So this much should be the work done on the object. This negative sign shows that the force is opposite to displacement. That means the force should be applied on the object in such a way that it opposes the motion of the object. Since this force opposes the motion, that is why the object finally comes to rest. Let us look at problem 5. It says calculate the work required to be done to stop a car of 1500 kg moving at a velocity of 60 km per hour. So what is the mass of the car? It is 1500 kgs. So it is moving with an initial velocity of 60 kilometers per hour. And what is the final velocity? Finally, I want to stop the car. So final velocity is 0. Let me convert it into meter per second. So this becomes 60 into 1000 divided by 60 into 60. So this becomes 16.67 meter per second. So we have to calculate the work done. So even in this case, we can say that work done is equal to force multiplied by displacement. Force is mass into acceleration, and what is displacement? We will again apply third equation of motion, that is v square is equal to u square plus 2as. So s becomes v square minus u square by 2a. So in this case v is 0, so this is equal to minus u square by 2a. So we'll put this value of s, that is minus u square by 2a. A and A will get cancelled, so this becomes minus half mu square, that is minus half m is 1500, and what is u square? 16.7 into 16.7. So this comes out to be minus 208,416.675 joules. So needless to say, what does this negative sign show? That the work done is negative. So it is negative work means force is opposite to the direction of displacement. Now let us look at the last problem of the lesson. It asks, find the energy in kilowatt hour consumed in 10 hours by 4 devices of power 500 watt each. So what is the total power involved? So the total power involved in this case will be 4 multiplied by 500, because 500 watt is the power of each device and you have a total of 4 devices. So this becomes 2000 watts, that is equal to 2 kilowatts, because 1000 watts is equal to 1 kilowatt. So this is 2 kilowatt. And for how much time the energy is consumed? The time is given as 10 hours. So therefore, we know that power is equal to energy transferred per unit time. So we can say energy will be equal to power multiplied by time. So power is 2 kilowatts and time is 10 hours. So this becomes 20 kilowatt hour. So this is the energy consumed in kilowatt hour in 10 hours by the 4 devices. Right? So I hope that with looking at these problems, it is little clear to you that how do we approach problems. So this lesson was relatively a simpler lesson. So it was just that you should understand the scientific definition of work. You should understand how is work and energy related, what is potential energy, what is kinetic energy, and you should have some idea about how to approach the problems. So practice more problems so that you can make your concepts clearer. So see you all in the next lesson. Thank you. Please visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thank you once again.